look at thermodynamics, right? Now, by definition, what is thermodynamics? As we've said earlier, we said thermodynamics is a branch of engineering science that deals with the study of properties of what? Matter as they are being affected by changes in temperature. Now, what it means is that when we say matter, what does matter mean? Anything that has what? Mass and occupied space. Now, in this context, we are also using the same idea. When we say property of matter, meaning the matter in this case can be what? Anything. That's where the terminologies of thermodynamics come in. The matter in this case is called system. We have thermodynamic system. I believe you should have heard that before. Thermodynamic system. Now, by definition, what is thermodynamic system? We will get there. We are going to get there. But you guys are taking note of what thermodynamics means by definition. We said thermodynamics is the study of the property of matter as they are being what? Affected by changes in what? Temperature. As they are being affected by changes in temperature. Now, terminologies used in this context. Number one is what? System. Number one is system, meaning the thermodynamic system. Number two, okay, I'll do a practical illustration. Thermodynamics terminology. The first one is system. The first one is system. Number two, boundary. Number three, surroundings. Now, you see how it works. Let's take the first one, system. System. Right, thermodynamic system. Thermodynamic system. By definition, what is thermodynamic system? Thermodynamic system is a fixed quantity of matter. It is a fixed quantity of matter whose behavior is under investigation. Thermodynamic system is a fixed quantity of matter whose behavior is under investigation. Now, illustration to that. The first one we said thermodynamic system. Thermodynamic system. Thermodynamic system. I want to look at these terminologies one by one, right? We are taking the first one, thermodynamic system. By definition, thermodynamic system is a fixed quantity of matter whose behavior is what? Under investigation. You will notice that when we define thermodynamic itself, we reference to what? Matter, right? We make mention of matter, true or false. Now, when we are saying thermodynamic system, we are still saying the same word, matter. Meaning that this matter, we need it here. And by matter, we said matter is anything that occupies, that has mass and occupied space. Now, let's give with that idea, let's do an illustration for this thermodynamic system. You know, as we get here, we are a system. Do you agree with me? You know, anybody can just come in. Let's say you are doing statistics. Our population of students here, including myself, our data can be collected. Our age can be collected. Our phone number, GPA, matric number, and more data. Do you agree with me? Yes. So what that means is that we all like this, we are a system. We being a system, they are investigating our behavior. They are investigating our behavior. And what is this behavior? It depends on the parameter. Let's say the behavior in this case is what? Name. It is name, phone number, matric number, department, I loved, and more data. Do you understand what I'm saying? That's a behavior. In some cases, it might be another what? Behavior. Do you understand what I'm saying? So as we are now, we are actually a system. Meaning our behavior can be investigated. So what it means is that whenever we are investigating, and you also agree that as we are here, we are occupying, we have mass, and we are occupying space, right? Meaning whatever space it is, or whatever system it is, you can investigate the behavior of that system when it comes to what? Thermodynamics. Now, let's say, illustration for that, let's say you have this system, consider this as your system. Say this is a system. Are you with me? Now, this system, okay, for better understanding, let me use what you all are familiar with. Say you have a cup. This is your cup, right? Then inside this cup, you have tea there. There's tea inside this cup. You know, from here, let's say this is A, let's say this is B. Let's say B, we have another cup. You have a T in there as well. The first one, the behavior of this first one varies. The behavior of this first one varies. This first one, okay, let me ask this question. The system in this case is what? It is the T. Are you getting me? I'm using T now. You might use anything. Okay, let's say water. Let's just use water. In this case, the system here is what? Water. Meaning the system in this cup is what? Water. And water it has mass and is occupying a space. Right? The volume varies, meaning it is occupying a space. Now, let's say this is A, let's say this is B. This first one, you are doing that the system is water. You want to investigate the behavior of this system, meaning you want to investigate the behavior of your water. For this A, your water might be cold or hot, right? Meaning, let's say this one, it is cold, while this one is what? Hot. And initially, you don't know if it is cold or hot, right? How do you conclude? How do you come into conclusion that this water inside your tea is cold or hot? How do you come into conclusion? You investigated the behavior. You have investigated the behavior. Meaning by the time you investigated the behavior of the water inside the tea, you know the what? You know if it is cold or hot. So that's what thermodynamic system is just saying. Then also, let's say you are holding this cup around your cup. Let's say that the water is cold. Let's say the water is cold, meaning for this first one. And the second one, let's say the water is what? Hot. By the time you hold this cup, what are you going to feel? Are you going to feel the coldness or the hotness? For this first one, what are you going to feel? Cold. For this second, what are you going to feel? Hotness. Where are you feeling it? Around that cup, right? Meaning around the what? The surrounding. Are you with me? What you are seeing here, this is the surrounding. Let's say this is your hand. This is the surrounding where you are going to hold your cup. This surrounding and this system, which is the water, there's something separating it. There's something what? Separating it. What is this thing that is separating it? It is what? The cup, which is what? Boundary. Which is boundary. I get what I'm saying? The cup, which is what? Boundary. So now, as far as thermodynamic system is concerned, we have two terminologies applied to it, which is what? Boundary and surrounding. Meaning there's no way you're talking about system that you refer to what? Boundary and surrounding. Alright, now take down boundary. Or before boundary, the second one, take this down first. Surrounding. Surrounding is anything outside the system that responds to the change that take place in the system. Now, the last one, boundary. By boundary, meaning the difference between the system and the surrounding. The difference between the system and the surrounding. Meaning this is my system. If this is my system, outside my system, it is what? Surroundings. Outside my system, it is surroundings. The difference between this system and surrounding, meaning this closed cup, it is what we call what? Boundary. It is what we call boundary. Any question before we proceed? We have type of system. Let me just be sincere with you guys. It might look boring, right? The introduction of thermodynamics. Say you are doing thermodynamics. We have a lot of theory. It might look boring to you. But when we start solving, you will see why we need to understand this theory that we are doing. You will see why we need to understand this theory. So don't look tired. Don't get tired. We need it. Alright, now, when we say types of system, basically, we have two types of system. The first one is open system, while the second one is what? Closed system. Types of system. The first one is open system, while the second one is what? Closed system. Now, from here, it is very easy for you guys to assimilate this, to learn the difference between these two systems. Very, very easy. Now, the two things that differentiate between these two systems, the first one is the quantity of matter. We want to differentiate between open system and closed system. We now said it is very easy for us to, without cramming, it's something that you can just, when they ask you, you'll be able to say it. Now, what distinguishes between this system, or the difference between these two systems? They are the quantity of matter, the quantity of matter, right? The quantity of matter, quantity of matter, and the second one is energy in form of heat and work. Energy in form of heat and work. A system is said to be an open system when the quantity of matter in addition to energy in form of heat and work. Quantity of matter when the quantity of matter and energy in form of heat and work can cross the boundary of the system to the surrounding. A system is said to be an open system when the quantity of matter in addition to energy in form of heat and work can cross the boundary of the system to the surrounding. Now, let me ask you this simple question. Since we said the difference between these two systems, this is it. If these two guys, both of them can cross the boundary of the system to the surrounding, what will happen to closed system? Any idea? Cannot cross, right? Cannot cross. Meaning, for your closed system, the one that can't cross the boundary of your system to the surrounding is what? Quantity of matter. While the one that can cross is what? Energy in form of heat and work. Energy in form of heat and work. So let's illustrate what we are saying. Let's say the first one. The first system. This is quantity of matter. Why this is energy? This is energy. The second one, this is quantity of matter. Why the second one is what? Energy. Now from here, say this is 1, say this is 2. Based on our definition, I want you guys to identify between 1 and 2. You will tell me which one is your open system and which one is your what? Closed system. Before then, let's recap what a closed system says. By definition, what is closed system? Closed system. Okay, let's start with open system. Open system says that
when the quantity of matter and energy in form of heat and work can the energy of a system to the surrounding.
All right. What about closed system?
In a system that the quantity of matter cannot cross while energy in form of heat and work.
What you are saying basically is that when your quantity of matter and energy in form of heat and work can cross the boundary of a system to the surrounding, it becomes what? Open system. When quantity of matter cannot cross but energy can cross, it becomes what? Closed system. Now, when we say energy, we said energy in form of what? Heat and work. Meaning in thermodynamics, we have energy. Basically, we have two types of what? Energy. The first one is what? Heat, and the second one is what? Work. So meaning in advanced class, you guys will treat heat separately. Heat is a topic on its own. Then you look at what? Work. Work is also a topic on its own. You understand what I'm saying? Okay, now from here, based on our illustration here, I want you guys to identify which one is open system and which one is closed system. So my first one, I'm saying I have this, then we have this and this. So based on our definition, between 1 and 2, which one is open, which one is closed? One is open, 2 is what? Closed. Alright. We said 1 is open, this is open system, this is open system. Why this is what? Closed system. Why this is closed system? Because in textbook, you will see this in textbook. So this is what it means. If whenever I see this in textbook, this is what they are telling you. Alright, now we said basically when we started, we said thermodynamic system. Basically, we have two types of system. The first one is open system and closed system. So there are more systems to this. We have the adiabatic system, we have the isolated system, we have the a lot of systems, right? We are going to see those systems later. When we start doing our types of process, thermodynamic process, adiabatic process, isochoric process, isothermal process, and what? Isobaric process. You know that for those processes, you'll be given a question. The question, each question, you know, this thermodynamic of a thing is an interesting course. It's very easy to pass. Yes. Are you me? Because using that question alone, you are just applying the condition. Giving a question, that question has a condition. So whatever the condition it is, you are applying it. Are you getting me? Let's say you are given a question and the condition for that question says that adiabatically expanded or adiabatically compressed. Meaning anything for adiabatically expanded, apply it. I know what I'm saying, but we will get there. If you don't look at this intro, when we get there, you will understand. So don't get bored yet. You see why I say that. Alright, moving on. We said we have other types of system. We can just take down. Other types of system. We have the adiabatic system. Other types of system. These are the basic type of system, open and closed. Now, other types of system. We have adiabatic system, adiabatic and isolated system. Isolated. For the first one, adiabatic system, meaning the system is thermally insulated. When we say adiabatic, meaning the system is thermally insulated. Now, for isolated system, when we say the word isolated, what does it mean? Isolated. When we say isolated, meaning it does not allow any of what we are saying, right? So by isolated, meaning neither quantity of matter, adiabatic, thermally insulated. The system is thermally insulated. Adiabatic. Adiabatic system and what? Isolated system. For adiabatic means that the system is thermally insulated. For isolated system, meaning neither the quantity of matter nor energy in form of heat and work can cross through the boundary of the system to the surrounding. Moving on, we've discussed type of system, right? Now, the next one, basic law of thermodynamics. Let's look at the law of thermodynamics. The basic law of thermodynamics. For the first one, we have the Zeroth law. We have the first law of thermodynamics. We have the second law of thermodynamics, and we have the third law of thermodynamics. We said basic law of thermodynamics. The first one, Zeroth law of thermodynamics. The second one is what? First law of thermodynamics. The third one is what? Zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and what? Third law of thermodynamics. The first one is what? Zeroth law. The second one is first law, second law, then what? Third law. For this first law, what first law is saying, is talking about thermal equilibrium. It's talking about what? Zeroth law rather. Zeroth law is talking about what? Thermal equilibrium. So take down. Right, in brackets for Zeroth law, thermal equilibrium. Thermal equilibrium, meaning temperature. Thermal equilibrium. First law is talking about what? Internal energy. First law is talking about internal energy. Second law is talking about converting it to work. Converting it to work. Now, second law is based on two statements. It is based on two statements. It is based on two statements. But you see it. This is just the introduction. Yeah, we take it last one. We said first Zeroth Law of thermal equilibrium. This came out. This is a exam question. This is an exam question. When we did our own exam, it came out. Right? So this first law, thermal equilibrium. This second one is talking about internal energy. Internal energy. First law is talking about internal energy. Second law is talking about converting it to work. While third law is talking about what? Entropy. It's talking about what? Entropy. We are still doing the introduction, right? We are still doing the introduction. When we start the proper class, meaning we are discussing first law of thermodynamics. We are going to see we are going to state the law itself, right? We are going to see the mathematical equation governing the law, right? Now, your first law is what? Based on conservation of energy, right? True or false? Do you agree with me? First law is based on what? Conservation of what? Energy. When we say conservation of energy, meaning what? Energy can neither be created nor destroyed. But that's the basic first law that we know. Now, you are normal in secondary school, right? Are you getting me? You are normal in secondary school. We are still talking about first law of thermodynamics. It's still under the basis of energy. It's still under the basis of energy. Meaning that first law of thermodynamics is talking about how your energy is being converted, how energy is being transferred. Yeah, let me put it that way. How energy is being transferred. But don't worry, you see that. Moving on, we said this second law is talking about what? Converting it to work. Converting it then the third one is talking about what? Entropy. Third law is talking about what? The first one, thermodynamics property. The second one, thermodynamics classification. Now, for this first one, thermodynamics properties. Thermodynamics properties. Under it, right? The properties that makes up thermodynamic system. The properties that makes up thermodynamic system. They are the temperature, pressure change, then volume, then lastly energy. What's the unit of temperature? This is what? Kelvin. Pressure change is what? Pressure is measured in what? Or Pascal, right? Volume is measured in what? Energy is measured in what? Alright, now, so these are the thermodynamics property. Thermodynamics property, we have temperature, we have pressure, we have volume, we have energy. So meaning that say you want to investigate a behavior of a particular system, you can use this property to investigate this system. Now, let me just give you a practical illustration. Let's say you have a gas of cylinder. You know, that gas of cylinder, in the morning, you can determine the temperature, right? You can determine the temperature. You can also determine the volume. That's in the morning. In the evening, meaning noon, you can also determine the what? The temperature and the what? Volume. Now, due to the weather, the temperature, will it be the same? No, exactly. It can never be the same. The question is, what are you trying to do? You are trying to what? Investigate what? The behavior of the fluid inside the what? Cylinder, right? Meaning in this case, the gas that is inside my cylinder is the what? System. Now in the morning, when we measured in the morning, the temperature is different from what? From the evening, right? Meaning at that instance in the morning, you are investigating the behavior. What we use to investigate the behavior, the property in this case is what? Temperature. The way temperature works, that's how other properties work too. Now say in the evening, you've also measured the temperature, you've gotten your value, right? You know what you did at that instance was that you investigated the gas inside your cylinder using what? Temperature. The same way temperature works, that's how other parameters work too. Now let me tell you this, meaning you are changing the state of that system. You are changing the what? State of that system. We are still going to define thermodynamic state, meaning you are changing from state 1 to state 2. Your state 1 in this case was in the morning. Let's say your temperature initially was T1, meaning in the morning I got T1 to be what? 20 Kelvin. T2, I got T2 to be what? 50 Kelvin. So meaning at state 1, meaning in the morning you have 20 Kelvin. In the evening at state 2, you have what? Temperature, which is what? 50 Kelvin. I'm not saying that the way we use temperature to explain the concept behind thermodynamics property, that's how it works for every property. Now let's say state 1, given a question, state 1, you have pressure, you have temperature, you have what? Volume, you have energy. This is for state 1. For state 2, you also have what? Pressure, you have temperature, you have volume, you have what? Energy. Can you see how it works? Don't worry, it will get interesting now. When we start solving, you see how it works. I told you earlier that thermodynamics is an interesting course. You are working with what you have. You are what? Working with what you have. Now, any question on this? No question. I want to believe you already understood the concept behind thermodynamics property now. Any question on thermodynamics property? Now, let's move to the next one. Thermodynamic classification. Thermodynamics classification. The first one is according to their variability with mass. Meaning a particular parameter is with respect to mass. Meaning a particular function is changing with respect to another function. Now, in this case, we now said according to their variability with mass, meaning that this thermodynamics property, how many properties do we have? We have temperature, we have pressure, we have volume, we have energy. Meaning, now we now have two types of thermodynamics classification. The first one is when it is not changing with mass. I get me? When it is not changing with mass. Why the second one is what? When it is changing with mass. The first one is what? When it is changing with mass. Why the second one is what? When it is not changing with mass. Now, when it is not changing with mass, what it simply means is that your thermodynamics property, they are not changing with what? Mass. Meaning it does not change with respect to what? Mass. Are you getting me? While the other one, it changes with respect to what? Mass. So this brings us to the two types of thermodynamics classification. So this brings us to the two types of classification we have under this variability with mass. The first one is intensive property. While the second one is what? Extensive property. The first one is what? Intensive property, while the second one is what? Extensive property. Now, for your intensive, this is the spelling. The first one, intensive intensive and what? Extensive. Now, for the first one, let's take down the first one. Intensive property. For intensive property, right? For your intensive property, meaning your thermodynamics property, they are not changing with respect to what? Mass. Now, when we say thermodynamics property, these are the property. That is, temperature is not changing with respect to mass. Pressure is not changing with respect to what? Mass. Volume is not changing with respect to what? Mass. Energy is not changing with respect to what? Mass. Now, how do you represent this mathematically under intensive property? Under intensive property, let's take these first two. Meaning that, okay, let's take pressure and volume. Meaning, okay, let me ask this question. When you say intensive property, what does it mean? What's the concept behind it? It means what? It does not change with respect to mass. Meaning, your thermodynamics property do not change with respect to mass. So let's take this first two. Meaning pressure and volume. That is, the P over the N, right, is equals to what? 0. And the second one is what? The V over the N is equals to what? 0. When you are saying is equals to 0, it means it does not change with respect to what? Mass. Now, for extensive property, if intensive property does not change with respect to mass, what will happen to extensive property? Extensive property change with respect to mass. So let's still use pressure and volume. That is, the P over the N is not equals to what? 0, and what? The V over the N is not equals to what? 0. Any question? Now, when we are talking about extensive property, the whole idea of this is that you'll be given a question. Your ability to identify these properties of thermodynamics given to me, are there specific property or extensive property? That's what we need here. Are you getting me at all? I said the whole idea of we knowing this classification, we knowing this property, is that at the end, you'll be given a question. Are you giving this question your ability to identify that these thermodynamic properties given to me in this question, are there specific property or extensive property? Is that understood? From my previous analogy, when I explained that we have state 1, we have state 2, you've seen that state 1, you have pressure, you have temperature, you have volume, right? In state 1. In state 2, you have pressure, you have volume, you have temperature. Now the question is, at state 1 and at state 2, you know, when I say pressure, temperature, volume, meaning thermodynamics property. So meaning at state 1 and at state 2, this thermodynamic property, is it extensive property or specific property? How do you know? Exactly. How do you know? Don't worry, you get there. Now, mathematically, for the first one, which is the P over the N. This is your intensive property, right? This is your intensive property. If this is your intensive property, so we said this guy is equals to 0, meaning there's no answer for this.
Yes.
There's no answer. Why? Because it is equals to what? 0. Now for the second one, which is what? Extensive property. Which is extensive property? Meaning the P over the N is now equals to what? 0. Meaning there will be an answer for this guy here. In this case, the P is what? The P is what? Extensive property. The P is what? Extensive property. That is, so we said it is now equals to 0, meaning there will be an answer, right? So in this case, your answer is called what? Specific property. Now, mathematically, relationship between extensive property and specific property. It says that your specific property is equal to what? Extensive property over what? Over mass. Now, take note, your specific property is always represented with a small letter. Right? Your specific property is always represented with a small letter. Meaning that, let's use volume to explain this. Let's say you have V is equals to V over M. What this means is that, call this equation 1. You know, this is what? But let's substitute their respective units. The unit of this will be what? Meter cube. The unit of this will be what? Kg. Call this what? Equation 1. This is, you looking at this volume. I'm having two volumes here, right? This volume is what?
The volume is specific property.
Why is specific property? Because it's represented with a small letter. Just like generally, specific volume is represented with what? A small letter. So you are saying, implementing this formula, applying this formula, which says that specific property is equal to extensive property over mass. Meaning the small letter of your volume is equal to the big letter of your volume divided by what? Mass. Now let's solve for specific volume and solve for the extensive volume. Now solving for in terms of unit, solving for specific volume in terms of unit, it becomes what? B is equals to what? M cube per kg. So all these 2, meaning 2 is what? Specific volume. Now solving for extensive volume in terms of units, what do you have? Cross multiply, right? Any question?
No.
Yes.
You have question?
Yes.
What's your question?
These are the letter denoted in bracket. Are they also specific?
This is their unit. In terms of unit, you want to see specific property of volume in terms of unit, specific property of volume in terms of unit, and extensive property of volume in terms of unit. So this is the specific property of volume in terms of unit. Now let's get the extensive property of volume in terms of unit. So just cross multiply. By the time you cross multiply, you have that big V is equals to what? Hello, big V is equals to what? Small v multiplied by what? Mass. Now substitute the unit of your specific volume. What do you have? M cube over what? Kg multiplied by what? Kg. You observe that Kg cancel out. You are left with what? Meter cube. So we are saying that generally your extensive property is still the same unit your thermodynamics property is having. Your extensive property is still the same unit that your thermodynamic property is having. Whereas your specific property, what does differentiate it is that divided by what? Mass. Divided by mass. Now, the next one, thermodynamic state. Right, thermodynamic state. The condition of a system at a particular instance as described by its what? Property. Meaning, you want to determine the state of your thermodynamic system. What you use to determine the state? It depends on the property of the system. Just like we've explained previously, say you measure the property of your cylinder gas in the morning and your cylinder gas in the evening. The temperature will vary, right? Meaning for the morning, you are determining thermodynamic state at that instant. That's how it works. Now, the next one, thermodynamic process. Now, right, for thermodynamic process, any activities in the system that cause the system to change from one state to another state, that's what we call thermodynamic process. Classifying thermodynamic process. Number 1, by types of system involved. Classifying thermodynamics process, right? Classifying thermodynamics process. The first one is what? By types of system involved. Meaning, you classify your process depending on the type of system you have. We have different types of system. We have open system, you have what? Closed system, you have adiabatic system, and so on and so forth. Now, for the first one, take down for open system. For open system, for open system, open system, you have a flow process. You have a flow process. For closed system, what do you have? Non what? You have non-flow process. You have no flows. Any question? Types of system involved. Let me just use involved. Meaning the type of system involved. We have the what? The first one is what? Open system. Meaning when you have an open system, meaning the type of process in that system is what? Flow process. The type of process in that system is called what? Flow process. If it is a closed system, the type of process is called what? Non-flow process. So this is the first one, by type of system involved. Now number 2, by the condition of the state of the system. Meaning we are making use of the initial state and the final state. You've seen yourself that when it comes to thermodynamic system, we have state 1, we have state 2. Now, for this one, the first one, if your initial state is equal to your final state, if your initial state, or say when your initial state is equal to your final state, meaning you have a cyclic process. When your initial state, when your initial state is equal to your final state, you have a cyclic process. The initial state is equal to what? Final state. Now, the next one, non-cyclic. If for cyclic state, initial state is equal to final state. For non-cyclic, what do you have? So write that. Initial state is not equal to your final state. For your cyclic process, meaning the initial state, say state 1. State 1 is not equal to what? State what? 2. Initial state, state 1, is not equal to what? Final state, meaning state 2.